Okay, well here goes nothing. So we're going to try and do a little bit of video, or I'm going to try and do a little bit of video teaching and see if I can get some of the major points across this way. And today we're going to start talking about stairs. So before we talk about my stairs, just in general, stairs, the rules for stairs are found in the BC Building Code in section 9.8. So when you get your copy of the Building Code, you can go there and get all the rules for it. And when you go in there, you're going to find out that there's three different kinds of stairs. There's private stairs, which is what these are. And private stairs are found in people's homes, used to get from one level to another level. There's public stairs. Those are stairs that you find in an institution, like at the school. And the rules for private stairs and public stairs are very similar. But public stairs are a little bit more constrained in the options that allow them, because a greater variety of types of people will be using those stairs. And lastly, there's service stairs, and service stairs will be found in places where only service people would be going. So maybe stairs into a boiler room or something, and you'll find that the rules for those stairs are the most open because they're being used by a very few number of people in very limited circumstances. So, this video is mostly going to be talking about the parts of the stairs, and I'll talk about a few of the dimensions that are really important when we're planning stairs out. Okay, so this is the underside of my stairs, and what I'm looking at here is the structural members that support the stairs. These are the things that hold your weight when you're walking up and down them. These are just 2x10s with a bunch of triangles cut out of them. These are called cutout stringers. There's one there against the wall, there's one in the middle, and if I get right in there, it's hard to see, but there's one in the corner up against the interior wall. The vertical pieces are the backside of things called risers, and there's the bottom of the part that you stand on, which is called a tread. So there are a number of ways that you can build stairs. These stairs are built using cutout stringers. And cutout stringers are just, like I said, a 2x10 with some triangles cut out of them. If you combine a cutout stringer with a piece of trim to make it look like the stair is actually going into the wall, you end up with something called a semi-housed stringer, which is what this is. And it's just a way of providing some trim beside the end of the stair for decoration. On a traditional stair, the outside was also served as decoration. Technically speaking, this piece of trim here is called a mitered stringer because this corner is mitered so that the riser piece and the stringer piece have got this nice finished corner. In reality, the way I built this stair is that I have a cutout stringer inside, and this is just a piece of trim. It's not serving any structural purpose whatsoever. The parts that you walk up and down are called treads. That's where you tread. And the vertical part is called a riser, or riser board. When we're calculating stairs, the distance from the back side of the tread to the front of the tread below it or above it is a critical distance. That's called the unit run. The distance from the top of the tread to the top of the tread above it or below it is also critical distance. That's called the unit run. Those two dimensions are based on the distance from the floor at the top to the finished floor at the bottom. In this case, the distance from the finished floor at the bottom to the finished floor at the top is 114 inches. So when I planned these stairs, what I did is I figured out what space would I have to make each individual step so that when they all added up together, you came to 114 inches. The distance from top to bottom is called the total rise. So if you added all these unit rises, this one plus this one plus this one and so on, bottom to the top, you should get 114 inches. And the unit rise on this is 7 and 5/8, which is 7.625. I'll count them so you can try it and see if the number of risers I have multiplied by the size of the riser does come to 114. There's 15 of them. 15 times 7.625 should be approximately 114. The unit run is not the distance from the riser board to the front of the stair. That's because, in most cases, stairs have a protrusion that sticks out the front. This protrusion is called the nosing. Typically, the nosing is 1 inch. These are 1 1/8. The tread depth, which is the distance from the back of the tread to the front of the tread, on these stairs is 11 1/8. 11 1/8 minus the 1 1/8 nosing gives me 10 inches. So the run of these stairs is 10 inches. We could figure out how long the stairs are from here to the top by multiplying the number of treads by 10. On these mitered stringers, we have to do something similar with the edge of the tread. This is called a tread cap, and this piece is also called a nosing return. Okay, tread cap is the term you're going to find in your textbook. So there are a couple of critical measurements that are based vertically from the stairs themselves. This line that I've created using my framing square that goes from the top edge of the nosing here to the top edge of the nosing here is called the nosing line. And this line is the line that we're going to measure vertically from for things like the height of the railing. If you look in section 9.8 for the railing height, it'll tell you that the railing has to be between 865 millimeters and 965 millimeters from that nosing line. If I hold my tape measure there and measure vertically, I have 35 1/4 roughly. 865 converted into imperial is 34 inches and 965 is 38 inches. So I'm at the lower end of the range, but within the building code specs. The other critical measurement that's taken from the nosing line is the headroom requirement. Think about going downstairs in a really old house and you have to duck when you're going down the stairs. Those stairs don't meet the headroom requirement. It was really common for houses built in the earlier part of the 20th century. The headroom requirement is measured from the nosing line. I'm going to see if I can line up here without So I'm somewhere around 79 inches. So what I've done is I've held the tape measure on the edge of the nosing, and I've tried to hold the tape measure plumb. And I'm just looking where the line from the ceiling here would hit the tape measure. That would be the headroom requirement. The distance so that you miss bashing your head on this corner as you go up and down. There's headroom requirements for public stairs and for private stairs. The headroom requirement according to the building code for a private stair like this one is 1,950 millimeters, and for a public stair it's a little taller, 2,050 millimeters. That number will come into play later when we're calculating how big we should make this opening. So this is called the stairwell opening. On this stair, it's 118.5 inches finished. And obviously this distance to this corner horizontally determines this distance vertically. So there's a relationship between this and this that's critical. And if you get it wrong, and you end up with a point here that's too low, and the building inspector comes and inspects your stairs during the final inspection to give you your occupancy permit. If it's too small here, he'll make you tear all this out and make it taller so people don't hurt themselves. Okay, the last thing I want to talk about are the components of a railing. So we don't actually call this a railing in construction. This is called a balustrade. And the balustrade consists of a handrail, and the handrail is the piece up on the top that you grab onto when you're going up and down the stairs. The building code says that the handrail portion of the balustrade's got to be grippable so that if somebody falls down it and goes to grab it, they can get a good grip on it so that they can stop themselves from falling. So this is the handrail. The rest is part of the handrail is a component of some total system called the balustrade. At the bottom of the balustrade, we've got a newel post. Because it's the bottom and it's starting the whole system, it's called a starting newel. Starting newels are commonly big and fancy, particularly in older homes. Each one of these little posts going up and down are called balusters. So the balustrade is made up of a handrail, newel posts, and balusters. Up at the top of my stairs, I have 3 more newel posts. This one is called a landing newel, as are these last 2 here. And the landing newel just is an end newel so that when the handrail comes up, it's got a place to end and continue into the guardrail up on the landing here. People don't use handrails when they're walking along a landing. So even though it's got the same piece of wood at the top, this is not a handrail, it's a guardrail, and it's stopped me from falling off the landing. In a lot of stairs, you could put a guardrail down the stair, maybe a wall, and then just screw some brackets on the wall and put a handrail on top of the brackets. You'll see that all over the place on walls such as this one, where there'll be a handrail down here, just mounted on brackets on the wall. So that's my video on the major parts of a straight staircase in a private residence. The rules, again, for a public staircase are very similar to private stairs, but you'll find them a little bit more constricting. But the names of all the parts will remain consistent. The last thing I want to show you are the notes that I made prior to starting this video so that I would have a basic script to follow along. It's got the spelling of some of the words on there, like balustrade, and you'll be able to use those when you're, well, to learn the vocabulary. I hope this works for you, and I'll see you soon.